All right, we're going to look at something new today, the polar coordinate system. So it's different than the rectangular system we're used to with X and Y. So let's just kind of look at it, okay? So we have this fixed point O. You can kind of think of it as like the origin to kind of compare it to the rectangular system. But it's called a pole or origin. From O, you can have this initial ray, and that is called the polar axis, which we can also think of to compare it to the rectangular as like the x-axis where x is positive. Each point P in the plane is assigned a coordinate. So instead of x, y, we have r theta, where r is the directed distance from O to P, or r is the radius of a circle. Theta is the counterclockwise directed angle. And then if r is negative, we will graph the positive r, but the theta will be theta plus pi. So let's look at graphing some. Okay, so I'm going to look at this. All of these things here are circles. So this one right here is circle of radius 1, circle of radius 2, circle of radius 3. All right, so that's going to be helpful to us when we go to graph. So this point A, we have 2 and 7 pi over 6. So what we can do is we can go to 7 pi over 6, so right here. And then we're going to graph with a radius of 2. So I see my 2 here, so I'm going to follow this line around. It's going to be right here. All right. B, let's see, we got a radius of 0.5 and an angle of 3 pi over 4. So let's see, 1 pi over 4, 2 pi over 4, 3 pi over 4, and then a radius of 0.5. So a radius of 1 is here, so 0.5 is this inner circle. It's going to be right there. 3 and negative pi over 3. Well, negative angles, remember they go clockwise. So if positive pi over 3 is here, and I see that as 1, 2, 3, 4 spots, the negative pi over 3 is 1, 2, 3, 4 spots here. And so radius 3 is that outer circle. So right here is C. D is negative 1 and pi over 4. So we can really graph 1, and then we can add pi. So if I add 4 over 4, I get 5 pi over 4. So I can go to 5 pi over 4. Which is here. And then the radius is 1. Or another way to think about it with the negative ones is I can go to where it would be for a positive. So pi over 4. And if I think of this being the origin and this being forward, then the negative tells me just the direction, so I can go backwards, so I can go this way instead. So that's one way of thinking about it. All right. So E. So let's try the forward backwards with this one. So 4 pi over 3. It's right here. So normally to go forward, I would be graphing the 2.5 in this third quadrant. But the negative tells me a direction. So I'm really going to go in this first quadrant. So instead of being here, I'll be here, and the radius is 2.5. So 2.5 is the one right between. And I can double check it by adding pi. So adding 3 over 3. So that'll make it 7 pi over 3. And the reason I'm moving that is because I have 5 pi over 3 here. So I'd have 5, 6, 7. And that's where I would be. Alright, and then let's see. Last one here. I could do negative pi over 6, which would be here. But I need to go the negative, so I need to go here and go 3. Alright. So each pair of coordinates, we actually could have more coordinates that mean the same thing, or like they're in the same spot. So we could say we have r theta plus 2n pi, or we could have negative r theta plus 2n plus 1 pi, where n is any integer. So let's look at a few where we're going to name more. So I have 2 and 5 pi over 3. And I only want to go from negative 2 pi to 2 pi. So right now the 5 pi over 3 is between so far. So I could add 2 pi. So I could have well, let's see if I add no. If I add 2 pi, it'll put me over 2 pi, because I would add 6 pi over 3, which would give me 11 pi over 3, which is greater than 6 pi over 3. So, can't do that. I could subtract. So I could subtract 6 pi over 3. So I get 2 and negative pi over 3. I could use the negative radius. So I could do theta plus 2n plus 1 pi. So I could have 5 pi over 3. And then let's see, I'll do n equals 1. So 2, that makes adding 3 pi. So let's see what that gives me. 3 pi would be doing... I don't like that because that's going to put me over 2 pi. Oh, hang on. If I trying to think. All right. So actually, if I think about where this original point is, I think that's going to help me better. So 5 pi over 3 is here, and going out to would be here. So another point I could have is if I were over here, but going the negative direction. So the angle that would be over there is 2 pi over 3. So negative 2 and 2 pi over 3. Let's see what else we could have. I could be going the negative direction. And right, and then another one would be instead of going to I could get hang on. I just had it in my head. It gotta be between negative 2 pi and positive 2 pi. The 5/3 would be the positive one. And then this 2 pi over 3 would be the other one. So I gotta think. I probably have another negative angle. Okay, I cannot think right now. Let's see. Some negative angles would be if we went this way. So I already have this point. So I need this one. So the angle, if I went this way in the negative direction, is going to be negative 4 pi over 3. But if I go forward, this would be 2. I need negative 2 because I need to be at this point. So negative 2 and negative 4 pi over 3. Okay, let's try one more. Let's do this one. So let me figure out where this one is. So let's see. Normal 7 pi over 4. 1, 2, 3, 4, 5, 6, 7 is here. So negative 7 pi over 4 would be 1, 2, 3, 4, 5, 6. It would be here. And then this is going forward. So we're actually here. So let's see. If I were to add 2 pi. Let's see where that would put me. That would be putting me 8 pi over 4. So if I add that, I'd be getting at pi over 4, which falls in my range. So I can keep my r as it was. Let's see, I wonder, can I add 2 again? No, it'll put me over, because that would be 9 pi over 4, and it would put me over. If I subtract, that puts me over as well. So, all right, now I got to think about the other directions. So I could think of here, but going the opposite direction. So, oh, which I literally already did. That's right here. So let's think. I could do, the positive 5 in this angle here, which is, let's see, that's 1, 2, 3, 4. That's 5 pi over 4. And then let's see, I don't have a negative angle, so I can go this way, and that angle would be 1, 2, that would be negative 3 pi over 4, and we'd be going forward, so 5 and negative 3 pi over 4. All right, I don't necessarily know if you need to do polar distance, but it's on this page, so let's run through one example. So I can give you a whole formula for it. So let's pretend we have 2 points. So point 1 is r1 theta 1. Point 2 is r2 theta 2. So the distance is going to be given by this formula. So the square root of r1 squared plus r2 squared minus 2 times r1 r2 cosine of the difference in the angle. So theta 2 minus theta 1. All right. Let's see. We got 2 points. Distance is the square root of r1. So 2 squared plus 3 squared minus 2 times 2 times 3 times cosine of the difference in the angles. So that's, I'll do it up here. Pi over 3 minus 7 pi over 4. Let's see, common denominator of 12. So 4 pi minus, I think I actually have them backwards, but it doesn't matter. It's just the difference between them. And 3, so 21 over 12. So it'll give me negative 17, so they have a difference of 17. So 17 pi over 12. And I can throw all of that in the calculator to get 4.01. Let's do another one. So square root. Actually, we'll do a degree one. How about that? So square root of 8 squared plus negative 2 squared minus 2 times 8 times negative 2 cosine of the difference in the angles. So 310 minus negative 175. So it's really plus. So cosine of 485. And we get, after plugging all that in, 7.05. All right, let's look at another idea here. Converting from polar coordinates to rectangular coordinates. And we'll go the other way as well. So, our polar coordinates is in r theta. We want to get back to x and y. Let me think. So, think back to like unit circle where we had, we had our x, our y, we had really, it was like cosine of theta and sine of theta. Well, in the unit circle, the radius is 1. So really, the cosine is, instead of x, it's really x over r. And sine is y over r. Just in the unit circle, the r was 1. So we didn't need that. So what we can think of is cosine theta equals x over r. So to get x by itself, we could just multiply both sides by r. So r cosine theta. And for the same reason, y would be r sine theta. Right? So we'll just look at a few of these. So x is r, which is 2. R is 2. Theta is 5 pi over 3. So x is 2 cosine of 5 pi over 3. And y is 2 sine of 5 pi over 3. So cosine of 5 pi over 3 is 1/2. So 2 times 1/2 is just 1. And then sine of 5 pi over 3 is negative root 3 over 2. My 2's cancel out, so I'm left with negative root 3. So my coordinates are 1 and negative root 3. Right. Let's just do the left side. So r and theta. So x is r cosine theta. So negative 1/4 cosine of negative pi over 2 is 0. So x is 0. Y is, r sine theta. Well, sine of negative pi over 2 is negative 1. So y is 1/4. So 0, 1/4. Let's do one with degrees. Doesn't really change anything. R and theta. So x is r cosine theta. Cosine of 140. I don't believe 140 is on the unit circle. So we can plug that in the calculator. Negative 0.766, which gives x to be negative 6.89. Y is 9 sine of 140. Sine of 140 is 0.6428. So that gives me y of 5.79. So negative 6.89 and 5.79. All right, we can also go the other way and go from our rectangular coordinates to our polar ones. So we're dealing with circles here. So the equation of a circle is r squared equals x squared plus y squared. So to get r by itself, we'll just square root both sides. So r is the square root of x squared plus y squared. theta, how can I think of this in terms of a triangle? You've got your x distance, you got your y distance, and we want to find theta. So we have opposite and adjacent. So we have tangent of theta equals y over x. So to get theta by itself, we do inverse tangent. So inverse tangent of y over x. So we'll just look at two of these. Okay, so we're going to convert it round, and we're going to be between 0 and 2 pi. It says give two possible solutions. We're just going to do one. So, r is the square root of x squared plus y squared. So 4 plus, let's see, 2 root 3 times 2 root 3 is 4 times 3, so 12. And 4 plus 12 is 16, and the square root of 16 is 4. Theta is inverse tangent of y over x. So let's see, the 2's cancel. So tangent, inverse tangent of root 3. So, let's see. We got to figure out where tangent is the square root of 3. So tangent is y over x. So to have the square root of 3 in the numerator, our options for tangent being positive are here and here. And being root 3 and having root 3 in the numerator, we would either have the negative 1/2 and negative root 3 over 2, or the positive 1/2 and root 3 over 2. And that happens both at pi over 3 and 4 pi over 3. So we could have 4 and pi over 3. And then the other one would be negative 4. I know I said I was going to do 1, but because I had both spots. Negative 4 and 4 pi over 3. Because you can think of it as, here's 1, right? And so the negative just tells me direction. So I'll just be down here. Let's look at one more. So let's see, r is the square root of negative root 3 over 2 squared plus negative 1/2 squared. So let's see, that's going to give me 3 over 4. And that's going to give me 1/4. Ooh, so that gives me nice. That gives me 4 over 4, which is just 1. The square root of 1 is 1. Now the inverse tangent one, let's see. Inverse tangent of y over x. So it's negative 1/2 times 2 over root 3. The negatives cancel out, so do the 2's, and to rationalize that, we actually get root 3 over 3. So we want, so tangent negative 1, we want where's tangent equal to root 3 over 3? Well, that tells me that we had a root in the bottom, so that's going to be a 3 over 2 and a 1/2. And that's going to happen at, and again we have 2 spots, it's going to happen at pi over 6 and 7 pi over 6. So we have 1 and 7 pi over 6. And I say that the 1 goes with the 7 pi over 6 because this coordinate already was already down here. So then the other one is -1 and pi over 6. All right, and there we have it.